Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, I'm going to be talking about how to find the refractive index of a glass block using the critical angle only, guys. So put down today's title, it's going to be how to find the refractive index of a glass block using the critical angle. Before we get going, guys, make sure you hit the like and subscribe button to keep my channel going, and obviously turn on notifications in case a new cool video pops up. So let's get straight into it with a quick recap on total internal reflection. Okay, so hopefully you have an understanding of what refraction is. It's when light changes direction due to a change in medium, and obviously the speed changes. So as you can see over here, I've got three diagrams right now. These are semicircular glass blocks over here. Don't worry, this is a semicircular glass block, everyone. Okay, so it's got a curved surface right now. There's a curved surface. That's why there is no refraction when it enters. As the ray of light hits the glass block, this will always hit at 90 degrees. That's why there's no refraction upon entry. As you can see right now, we're going from the glass into air. So let's call this one N1. Obviously, it's the medium that I'm first traveling in, and this one will be N2. So clearly we know that the refractive index matters here. So we're going from more dense to less. So therefore I'm going to say refractive index of N1 is greater than N2 over here. As you can see, guys, we're going from more dense to less dense. That's why it's bent away from the normal here. So right now it's being refracted out of the glass block. But if you keep on increasing this angle, the angle of incidence, look, as you further you make it, eventually you will hit the critical angle here. At the critical angle, we can see that the angle of refraction is 90 degrees. It's 90 degrees going across here. Can we see that? Right, so obviously initially we can say that obviously theta 1 is less than the critical angle. That's why we get refraction. Therefore, refraction observed. So refraction observed. And then look, we can say that when you get the angle of incidence is equal to the critical angle, so now when theta 1 is equal to C, and don't forget C is the critical angle, we can see that the angle of refraction will be what? The angle of refraction is 90 degrees. Therefore, R is 90 degrees. R is equal to 90 degrees here. Okay, so that's the critical angle, guys. So the critical angle, guys, is the angle of incidence in which the refracted angle is 90 degrees, or along the boundary here. Okay, so what happens if theta 1 is greater than the critical angle? We can see that the light won't even go across the boundary. It will be reflected by that edge of the glass. This is known as total internal reflection. So therefore, total internal reflection occurs. Wonderful stuff. Total internal reflection occurs. So that's theta 1 over here. And obviously you've got to be able to identify when is it going to be refracted, when is it along the boundary, and when total internal reflection occurs. But for today's lesson, make sure you understand that for C, this angle of incidence, that will be the critical angle, and the refracted angle is 90 degrees. Okay, so how are we going to tie this to the practical? Let's tie it all into the practical. So don't forget, our task is actually to work out the refractive index of the glass block using the critical angle. So look, you're going to set up the following experiment. So obviously you get your semicircular glass block, you have your ray box. I'm going to draw your ray box over here. This is obviously your ray box. And obviously the light is going to be incident. There we go, matching up. So all you do is you find C experimentally. So you change the angle of incidence and you record when you find the critical angles. So you, number one, find the critical angle. Good, you find the critical angle. So now that you've got the critical angle, we're going to actually work out the refractive index of the glass. We're going to need Snell's law to be able to do this. So we remember that N1 sine of the angle theta 1 is equal to N2 sine of the angle theta 2 over here. The refractive index of the first medium is obviously this one over here. So this is N1 because we're traveling in this one first, and obviously this one is N2. Don't forget, N1 is glass. So N1, we're going to say that's going to be the refractive index of glass. And the next one, N2, is going to be obviously the refractive index of air. Okay, the refractive index of air, guys, is equal to 1.004. Or we're going to take it as equal to 1 today, approximately equal to 1. Right, so now we're going to rewrite our formulas. So we now know that when theta 1 is equal to C, Therefore, the angle of refraction, or theta 2, will be equal to 90 degrees. Okay, yeah, look, it's 90 degrees there. Theta 1 is equal to c. Now, into our formula it then goes. So it's going to be the refractive index of glass, because that's n1, don't forget that's n1, times by sine of the angle c will be equal to the refractive index of air, n air, times by sine of the angle theta 2, but theta 2 is 90 degrees over here. Right, so hopefully we can remember that sine of the angle 90 is equal to 1, and the refractive index of air is also 1. So on this side of the equation, guys, we've got 1 times by 1, yeah, because sine 90 is 1, refractive index of air is also 1. So the refractive index of glass is equal to 1 times by 1 divided by sine of the angle C, which therefore becomes refractive index of glass is equal to 1 over sine of the angle C. So obviously if you do this experimentally, you will find that you take the value of the critical angle, then you just do 1 over sine of it, and you'll work out the refractive index of the first material here, over here. So in general, obviously you might not see it as glass, you might just see it as n is equal to 1 over sine of the angle C here, guys. Wonderful stuff. Obviously this is a very different method compared to the previous one, in which we were going from air into glass when we plotted sine theta 1 against sine theta 2, and the gradient of the line was the refractive index. In this practical, obviously I just worked out the critical angle, measured it once, and I can get it quickly. If you're struggling with that practical, make sure you watch my other video, guys, and that will obviously tell you how to do it. So we've proved it right now. The refractive index of the material is equal to 1 over sine C. Let's have a quick recap right from the top. Okay, so today's title was going to be how to find the refractive index of a glass block using the critical angle. And then we discussed what total internal reflection was. We can see that when theta 1 is less than the critical angle, refraction occurs. When theta 1 is equal to the critical angle, it goes along the boundary. When theta 1 is greater than the critical angle, we know it's reflected inwards. So obviously, at the critical angle, the angle of refraction is 90 degrees here. And obviously don't forget that the refractive index of the first material is greater than the second one. You're going from more dense to less. You're always going from more dense to less. Then experimentally, we said, how would you work out the refractive index of the glass? Well, very simple. Well, you can find the critical angle, the angle of C, with a ray box. You just simply see when the ray of light goes along the boundary, record that value of C, then look at your formula for Snell's law. N1 sine theta 1 is equal to N2 sine theta 2. So the refractive index of the first material, we're going to denote that as N glass. The refractive index of the second material is the refractive index of air, which we're going to approximately equal that to 1 over here. So when theta 1 is equal to C, theta 2 is equal to 90 degrees. So look, refractive index of glass times by sine C, and replace theta 1 with C, is equal to refractive index of air, which is obviously going to be 1, times by sine 90. Sine 90 is 1, refractive index of air is 1, therefore the refractive index of glass is 1 over sine C, or n is equal to 1 over sine C overall. And that's it, guys. Make sure you hit the like and subscribe button to keep my channel going, and good luck in your studies. Bye bye.